This meeting is being recorded.
For problem 19 in chapter 4, we are given 4 cases and 4 different bond line structures, and we are asked to view down a specific carbon-carbon bond and determine what would be the highest and the lowest energy conformations. So we're going to follow some similar steps for each of these parts. We're going to begin by converting our bond line drawing into a Newman projection, and then we'll do some conformational analysis and determine if we have the highest energy conformation, lowest energy conformation, and if there are any degenerate conformations as well. So for part A, we see if we look down this line of sight, this would be our first carbon that we see. So we have these 2 methyl groups pointing up in the on the front carbon, and then one pointing down. So we see front carbon here on that dot with 3 methyl groups. Then the second carbon that we see, we have this methyl group pointing up, and then we have a hydrogen pointing down to the left and down to the right. So this would be the staggered conformation, the lowest energy conformation for this structure here. And then below, we see if we were to rotate each of these groups slightly, we would see that in our eclipsed form, we have 2 methyl groups eclipsing and then a methyl and hydrogens eclipsed here. This will be our highest energy conformation. So that's it for part A. Let's take a look at part B. So here's our line of sight. We see our first carbon there, and then our second carbon here. So that first carbon, we see a methyl group pointing up to the right. We also see a hydrogen pointing up to the left. And then we see this ethyl portion here down. So that's our front carbon, and on our back carbon, we should see that we have the ethyl group now pointing up, and then we have a hydrogen down to the left and down to the right. So this here would be the anti-conformation, where the 2 ethyl groups are as far away from one another as possible, and this would be our lowest energy conformation. So this is our lowest. And then what we see down here is if we rotate that carbon-carbon bond, if we place the 2 ethyl groups in a spot where they would be eclipsed, like so, this would be our highest energy conformation. For part C, we have some degenerate structures. So to save time, instead of drawing all these out, I have copied in the degenerates for the lowest energy here and the degenerate conformations for the highest energy. So let's review. We have our first carbon in our line of sight there. So we have a methyl group up, a methyl group down, so up to the right, down, and then a hydrogen up to the left. That's what we see here. And then on our second carbon, we have a methyl group pointing up, and then we have 2 hydrogens down to the left, down to the right. So we see here that we have this one gauche interaction, and we could rotate this structure, and we would see, again, a degenerate structure that has only one gauche interaction. If we rotated this methyl group up and we ended up with 2 gauche interactions, this would be a higher energy, not the highest, but it definitely would not be the lowest. The 2 forms here shown, these 2 degenerate conformations would be our lowest energy. And then down below, we have a degenerate highest energy conformation as well. That's when we see these methyl groups fully eclipsing here and here. So these are degenerate, and then all we have are eclipsing methyls with hydrogen, so this would not be the highest energy. It would be higher than the lower energy forms, but it doesn't have that fully eclipsed methyl groups. So this would be our degenerate highest energy conformation for C. And in the last example here, example D, we'll start here with our front carbon, and we have a methyl group pointing up, we have a hydrogen pointing up, and then we have this ethyl group here pointing down. So we see that. And then on our second carbon, we have something similar. We have an ethyl group now pointing up. And then we know that we have two hydrogens as well, down to the left, down to the right. So this would be our lowest energy. Again, we have the anti-conformation. So if the two ethyl groups are anti to each other, that would be our lowest energy conformation. The highest would be if the two ethyl groups were eclipsing one another. So we have the lowest energy structure here and the highest down here.